to 4.5, completing the square. Okay, guys, this is kind of a review from a while back, but I want to make sure that you are comfortable with a concept that we have talked about, and that is perfect square trinomials. So what is a perfect square trinomial? Let's just review that. A perfect square trinomial is when you have a perfect square. Okay, so we can choose with that to be whatever we want, but when we're dealing with quadratics, typically, well, not typically, we will always have an x squared term. Okay, so a perfect square trinomial occurs when we have a perfect square for the first term and a perfect square, so it could be written as something squared for the last term, and then in the between we have 2 times those two things, whatever those two things are. Okay, so notice here, if I have something like x squared plus 4x plus 4, okay, what you're doing to identify if you have a perfect square trinomial is you look at the first thing. Can you write that as something squared? Yes, you can write it as x squared. Then you look at the last thing. Okay, in this case it's this, well, it's always going to be the a term and the c term. Okay, so the c term here is 4, so can that be written as something squared? Yes, it can be written as 2 squared. Okay, and can the middle term be written as 2 times those two things? So 2 times x times 2, does that give me 4x? Yes, it does. If that is the case, this is considered a perfect square trinomial, where the first piece is a perfect square, the last piece is a perfect square, and the middle piece is 2 times the roots of those two things. Okay, so that's what I just identified. Once you've identified that something is a perfect square trinomial, what's nice about that is that it factors very nicely. Okay, it's always going to be the same factor twice, and that's what it comes out to, with the sign that is here. So I know I'm going to have something plus something else squared. What are the somethings? Well, they're the two things you came up with. So x and 2. So x plus 2 squared are the two factors of x squared plus 4x plus 4. And if you don't believe me, you can go ahead and FOIL that out. Right? So if you FOIL that out, you get x squared plus 2x plus 2x plus 4, which is just x squared plus 4x plus 4. All right, so these are perfect square trinomials, and you'll need to identify those today. The square root property is what we're going to do for the first two examples. Works nicely when you're dealing, big if here, if you're dealing with a perfect square trinomial. So I do want you to practice identifying if something's a perfect square trinomial. We'll do that together in this lesson. But once you have that, it's very easy to solve using the square root property, which I'll show you. Okay, so example 1, let's identify. Do we have a perfect square trinomial? Can we write this thing as something squared? In this case, it'll be minus something squared. Okay, so I'm not going to worry about this 25 at the moment. I'm just going to look at this side of the equation. And here I notice that I do have an x squared, that's a perfect square, and then 36 can be written as 6 squared, and then 12x can be written as 2. Remember, it's 2 times, let's check to see if it's those two things, x times 6. Yes, 2 times x times 6 gives me 12x. Don't worry about the sign. We'll cover the sign here. Okay, so if this is the case, what this thing factors to is x minus 6 squared. All right, and today what we're going to do is we're going to bring this 25 in. We're going to say, sorry, make that 2 a little better. We're going to say, okay, I can solve this now because I have a perfect square here. I can just take the square root of both sides, right? So if I take the square root of this goes away. Take the square root of that, I get a nice number in this case. So this will be x minus 6 is equal to plus or minus, don't forget it's going to be plus or minus whatever this root is because we took the square root of a variable here. Okay, so we have to consider the positive or the negative. Okay, so plus or minus 5. Let's add 6 to both sides to get x by itself. So it's x is equal to 6 plus 5, which is 11, or 6 minus 5, which is 1. All right, so there's that one. Let's do another one. Can I write this as a perfect square trinomial? Let's check it. I always do this just to take a look at it. So yes, I can put an x in there and make that x squared, and I can put an 8 in there to come up with something equivalent there. Middle term, 2 times x times 8. That works. That gives us 16x. So this can be written as x minus 8 squared is equal to 49. Let's take the square root of both sides. We get x minus 8 is equal to plus or minus 7. Let's add our 8 to both sides, and we get x is equal to 8 plus 7, which is 15. 8 minus 7, which is 1. There's my two solutions for example 1. And let's look at example 2. This is when we don't have really nice numbers here for our answers. That's really the only difference. So again, this can be written as this is a perfect square trinomial. Okay, so I have x plus 4 squared. Okay, this is 2 times x times 4. That works. Plus sign, that's how I get my plus sign. This is equal to 20. Take the square root of both sides. I get x plus 4 is equal to the square root of 20. Plus or minus, right? And then x is equal to negative 4 plus or minus root 20. Now, I think in your homework, they have you round this to the nearest hundredth decimal. Okay, so you'll want a calculator for that. If you take the square root of 20, and you know what, I don't mind if you guys leave it in radical form. That's not a big deal. But if you take the square root of 20, you will get, let me just do this here, square root of 20 is 4.47. So x is equal to negative 4 plus or minus 4.47. Okay, I don't care if you leave it that way, I guess, or you can write this as 0.47, and then if you have negative 4 plus, minus 4.47, you'd be at negative 8.47. So if you want to kind of know exactly where it crosses that x, that would be your solution. This would also be an acceptable answer. This one, if you're going to go radical, make it simplified radical form, so that's the same thing as square root of 4 square root of 5, so that'd be 2 root 5. But then that would also be an acceptable answer if you did negative 4 plus or minus 2 root 5. So there's a number of formats for this, but I believe the format that they're going to use in the back of the book is rounding to the nearest hundredth because it's the most meaningful on a graph. Okay, so let's keep cruising here. Let's change colors to blue. All right, so this one can be written as x minus 3 squared, perfect square, 2 times the roots, right, is equal to 32. Take the square root of both sides. I get x minus 3 is equal to plus or minus root 32. And then x is equal to 3 plus or minus root 32. If you take the square root of 32, you get, let me just do this quick on my calculator here, you get 5.66. So this is x is equal to 3 plus or minus 5.66. Okay, so that would give me the two solutions of negative 2.66 and 8.66. If I took 3 plus that or 3 minus that, you would end up with these two things. All right, all of that is kind of leading us up to the main point of the day, which is completing the square. Okay, so to complete the square, you guys, what you're going to do is you're going to take half of the middle term, or the x term, I should say, the x term, okay, the b term, and square it. And then we're going to add it in to our quadratic. What does that mean? Okay, so let's just take a look. So this can be a little bit confusing if you're not looking at an actual example. The b's can always get you confused. Don't worry about it too much. Look, if you have something like this, x squared plus, let's make it a nice one to start. Let's do 6x. Okay, if they said complete the square here, what they want you to do is they want you to take half of the b term, which is 6. Okay, half of 6 is 3. Then they want you to square it. 3 squared equals 9. And they want you to always add. It'll always be adding because anything squared is going to be positive, right? They're going to want you to add that solution back in. Now notice, what did that do? That just created a perfect square trinomial, the thing that we've been working on for the last couple of examples. The reason that we do this is because we know that this factors nicely, right? So now I know this is going to factor to x plus 3 squared. So this is actually a universal way of factoring. It works for any quadratic. And this is actually how they derive the quadratic formula. It comes from just the steps that you would take to complete the square. All right, so if you're interested in that, I always give an extra credit possibility on a test if you can derive the quadratic formula from the method of completing the square using A's, B's, and C's. So anyway, if you're interested in that, let me know. So this becomes out to this, and we're done. That's how you complete the square. Okay, so completing the square, take half the middle guy, square it, add it in. Let's look at this. Example 3. Find the value of c that makes x squared minus 14x plus c a perfect square. Then write the trinomial as a perfect square. Okay, so we're going to use the same method we just talked about. We're going to look at the middle guy. Half of 14 is 7. It's technically negative 7, but it doesn't really matter because we're going to square it. 7 squared gives me 49. Okay, so x squared minus 14x plus 49 would be my perfect square trinomial. This always factors to the root of this guy, the root of this guy. So x with this sign in the middle there. So x minus 7 squared would be writing it as a perfect square. Okay, so that's example 3. So there's 2 answers there. The value of c would be 49, right? And then writing it as a perfect square. All right, so example 4. Solve this by completing the square. Now, this is where it gets a little bit, it turns a little bit different here, but it's really not too bad, you guys. So watch. They want a perfect square on the left side of the equation. What's on the right side doesn't really matter. So what I'm going to do is I am going to first here check to see if this is a perfect square. So can I write this as something squared and something squared? No, because there's nothing squared that gives me 24, nothing nice at least. Okay, so this is not a perfect square trinomial, so I'm going to make it one. How do I make it one? I get rid of this 24 from both sides, right? I can do that because I'm doing it to both sides of an equation, on either side of an equal sign. Okay, so what I get now is that x squared minus 10x, I'm going to leave a space there, but I'm going to say plus something is equal to negative 24. Now, we haven't talked about this, but if I add something in to make a perfect square, I actually have to do it on both sides of the equal sign. All right, so remember that this is a balanced equation. So if I add something in, I've got to add it in on both sides. Okay, so let's complete the square. What is half of 10? Half of 10 is 5. 5 squared equals 25. So 25 is what I'm going to add in here. Okay, and before I forget, I'm going to add it to both sides. All right, now, what does this factor to? Well, you just created a perfect square trinomial. So x is the root of this. The root of 25 is 5 with a negative sign in between. X minus 5 squared is equal to 1. Negative 24 plus 25 is 1. Take the square root of both sides. So I get x minus 5 is equal to plus or minus the square root of 1, which is 1. Okay, and then move your 5 over, you get x is equal to 5 plus 1, which is 6, 5 minus 1, which is 4. So my 2 solutions to this are 6 and 4. All right, now try this one. Now here, I do get a perfect square here, right? And this one's also perfect square, but let's check the middle. Is 10x the equivalent to 2 times x times 3? And the answer to that is no, it's not. So this is not a perfect square trinomial, even though it kind of appears as 1 at first. So you always got to check that middle guy to make sure that that holds up as well. Okay, so it's not. Let's move the 9 over. So I have x squared plus 10x. We're going to subtract 9 from both sides, and we get is equal to negative 9. We're going to add something here, add something here. What's the something? Well, half of 10 is 5. We already did that last problem. 5 squared is 25. So I'm going to add 25 to both sides. And then my perfect square trinomial factors nicely to x plus 5 squared is equal to, in this case, if I take 9 away from 25, I end up with 16, which is a nice number. So that's good. So I take the square root of both sides. I get x plus 5 is equal to plus or minus 4. And subtract 5 from both sides, I get x is equal to negative 5 plus or minus 4. Negative 5 plus 4 is negative 1. Negative 5 minus 4 is negative 9. So there's my two solutions for example 4. Sorry guys, we're almost done. I got a couple more examples to work. Here we're solving this by completing the square. It says, notice I make it a special notation here for you. It says you must make a equal to 1. So how do I make a equal to 1? Well, what I'm going to have to do here is I'm going to have to divide out whatever a is. Okay, so I'm going to divide it out by everything. So it kind of gets a little sloppy here, but it's not too bad. If I divide by 3 away from everything, so I took 3, I divided everything by 3, what I'm left with is x squared plus 10 thirds x minus 8 thirds equals 0. Okay, now I'm going to do the exact same thing I've been doing. All right, so I'm going to move my 8 thirds over. So I get x squared plus 10 over 3x is equal to positive 8 thirds. This is always going to be plus something plus something. Okay, so now, how do I figure this out? If I have 10 thirds here and I take half of that, well, one easy way to take half of something that's ugly like this is to say, well, you could do 10 thirds in your calculator, 10 thirds in your calculator, I guess, and divide by 2. But you know that dividing by 2 is always the same thing as multiplying by 1/2. So you can multiply by a half, and if you do that, you get 10 over 6. Okay, so 10 over 6 squared, got to square that, and then put that number in here. So to square this fraction, remember how to square fractions. You apply that square to both numerator and denominator. All right, so if I do that here, I'm going to get, and I like to keep that 10/6 there, but I'm going to get 100 over 36. Okay, so this is the same thing as 100 over 36. I'm going to add that in on both sides. Okay, and now, I know this is a little bit much, but just hang in there, you guys. I'm going to change colors. This is going to still factor nicely, but it's going to have a fraction in it, right? So it's going to be x plus whatever this guy was. So x plus 10/6, which you could reduce, but that's okay. We'll just leave it like this for now. Squared is equal to, now if I add these two together, I'm going to have to make a common denominator. Right, so 3 times 12 gives me the 36. And then 8. So I can multiply 8 thirds by 12 over 12 to get us into 36. I believe that's 96. So this is equal to. So this whole thing is equal to 96 over 36. Okay, so if I add that to 100, I get 196 over 36. So this is equal to 196 over 36. Okay, now what you might want to do at this point is you may want to reduce that fraction. Okay, so that's okay to do at this point. We can reduce fractions, or we could just keep going and see what happens here. So if you take 196 and divide it by 36 in your calculator, you get 5.4 repeating. Okay, then if you take the square root of both of those, so let's just do this. This might turn out better if we just go like this. Let me go into green here. So let's do this. Let's take the square root of both sides. So x plus 10 over 6 is equal to, let's just reduce this right now. Okay, 10 over 6 is the same thing as 5 thirds, right? I don't know if that'll help us or hurt us here in the end, but let's just try that. Okay, so we have x plus 5 thirds, okay, is equal to, if I take the square root here, the square root of 196, let's take the square root of 196, we get 14, and the square root of 36 is 6. All right, so maybe it did hurt us. Let's go back to our original. I apologize, you guys. Let's keep this as 10, 6. We're dealing with 6 here at the end. Okay, so now, this is plus or minus, right? So now I'm going to move my 10, 6 over. So x is equal to negative 10, 6. I just subtracted 10, 6 from both sides, plus or minus 14, 6. So if we do this out now, negative 10 over 6 plus 14 over 6 gives me negative 4, positive 4, 6, which is 2 thirds. Negative 10, 6 minus 14 over 6 would be negative 24 over 6. Negative 24 over 6 is equal to negative 4. So my two final answers, 2 thirds and negative 4. Whew, that's a tough one. Okay, so same deal on 5b. I'm actually going to, for the purposes of time, I'm not going to do this with you, but I encourage you to do it on your own. The solutions that you should get for 5b would be 2 and 8 thirds. So just make sure that you can get those for 5b, and then we're gonna finish this off with some imaginary examples for example 6. So example 6. What we're going to do is we're going to complete the square, but when we do this, we're going to have a negative number in our square root, which is going to turn us imaginary into the imaginary number line. Okay, so let's do that. So if we subtract 2 from both sides here, we get x squared plus 2x is equal to negative 2. And then we're going to add in a perfect square trinomial. To make this a perfect square trinomial, half of 2 is 1. 1 squared is 1. So I'm going to add 1 to both sides. This factors to x plus 1 squared is equal to negative 1. Take the square root of both sides, I get x plus 1 is equal to plus or minus the square root of negative 1, which we know now as I root 1, or just I in this case, right? Because the square root of 1 is 1. So I is equal to the square root of negative 1. Okay, so we have x then is equal to, if I subtract 1 from both sides, negative 1 plus or minus I. And again, keep your i's separate from everything else. If they want you to write this out, it would be negative 1 plus I, negative 1 minus I, but I'm okay with this answer right here. Okay, same deal here. We have x squared minus 6x plus 9 is equal to negative 25 plus 9. I just made this into a perfect square trinomial. So this is x minus 3 squared is equal to a negative 16. And then x minus 3 is then equal to plus or minus 4i, right? Because the square root of 16 is 4. Take the negative out and get an I. So then we have x is equal to 3 plus or minus 4i. So there are some imaginaries in there for you in example 6. That's it for now, guys. We'll catch you guys next time.